Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Enroll now.
Geeks learning together.
Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes, way. Don't delay and enroll now.
Geeks learning together.
Hi and welcome to Geeks for Geeks. So quickly give me a one to mark the attendance. So today Abhinav won't be taking the stream, rather I would be taking the stream, and tomorrow's stream would be taken by Yash Trivedi. So I think most of the audience of this practice is a little bit acquainted with my face as well as Yash Trivedi's face. Needless to say, I would still introduce myself. So hi, I'm Sadat Hazra. Currently, I'm an intern at Geeks for Geeks. I'm currently in my fourth year in Netaji Subhash Engineering College. Okay, so we would start in just 1 minute. I think 1 minute cooldown is required. So we would talk about a little bit what would be doing, what would be the agenda of today. So if you're someone who has already well acquainted with the things that would be going on today, I suggest you that you can just watch the recordings in 2x speed so that you would have a good revision and the time of your attendance could also be saved. Okay, fair enough. So I would quickly just answer your doubts. So will you please add the problem links in description? Sorry, actually the thing is I can't really edit the description at the moment. But still, what I can do is I would just provide you the links to all the problems that would be done today. Okay, so I would just quickly tell you the agenda of today. So today the agenda would be that I would be starting off with graphs. What is graphs? Okay, and then we would be moving forward and we would be learning about the representation of graphs. Then we would be learning about traversals in graph. So basically we would be digging deep into two traversals, that is breadth first search and depth first search. And then we would be learning what is the use of breadth first search, what is the difference between the breadth first search and depth first search, what is the different what is the use cases of this. Okay, so I've joined your past session. Yeah, Nakaj. I remember Nakaj, Sneha. Okay, I remember some of the faces. Okay, fair enough. So the very first would be that I would be attaching an example, as you all know. So then I would be taking forward the example, and so the way to mark your attendance, the way to submit your problems would be done by you. So the very first problem is that we would be doing is after the introduction of graphs, the very first link of this problem is this. Then we would be doing this problem, okay, that is BFS of graph, and then we would be doing this problem, which is a medium level problem, and this problem is nothing else but an application of their nice background. You have noticed this now, I think. Okay, this background would change soon because I would be shifting to a new place. Okay, and I can't really help it. You might encounter some background noises of crackers that is going around in my colony. And I think there is no way I can stop them. And I don't think it is ethical enough to stop them. So we should leave them as it is and we should continue our job. Okay, fair enough. So let's start. Okay, so let me just present my screen. Belated Happy Diwali. Yes, Happy Diwali, everyone. भूल गया विश करना, sorry. Happy Diwali, everyone. Today, Diwali seems to be a pain. Why? Because those who are working, they need to get back to the work today, and we don't really feel like working the day after Diwali. Okay, so let us start. Okay, fair enough. So, what I would be telling you is whenever you are learning about graphs, okay, so the very first thing is whenever you are learning about graphs, the very first thing is that you should visualize the graph in terms of network of roads. Network of roads. Okay, like the highway network, national highway, state highway, these all things. And whenever you are learning about trees, visualize it in the form of family tree. Okay, because all the principles of trees could be understood well enough with this illustration, and all the examples of network graphs could be well understood by the illustration of network of roads. So basically, what is graph? Okay, so quickly tell me the state in which you are living. Then I would be moving forward because I would be using network of roads. Network of roads is so my city is Dhanbad. Okay, quickly comment down your city. I would be using it. Quickly comment down your city. Quickly. Shubham, Adarsh, Sevak, quickly. Okay, chalo, we have. So we have some. Okay, so let's take the advantage of them. So we have Uttar Pradesh from where is Yash Dwivedi. Okay, and then we have Hyderabad is a great city. So we have Kanpur also. Okay, and then we have Tamil Nadu. Okay, trying to keep it as realistic as possible. Okay, fair enough. काफी realistic सा है. So we can see we have people from London. Vikas Patel, fair enough. That's a good one. So there are cities like Dhanbad, UP, Tamil Nadu, and Kanpur. Kanpur. So what we can say is we can safely say that there is a road between Dhanbad and Tamil Nadu, and there is one more highway via this. Okay, via UP. We say this. Okay, and then we have Dhanbad and Dhanbad to Kanpur. Fair enough. So this is basically a graph. Okay, this is basically a graph where we have Kanpur, we have Tamil Nadu, we have UP, and we have Dhanbad. So just you can, as you can observe, the way to reach Dhanbad from Tamil Nadu is a direct by visiting this. Sorry about this. Is a way by visiting this, as well as by taking this path. Okay, either of the way is a valid way. So now the next thing is that, see, if we say that this is national highway, okay, network of roads, this is a national highway, okay, this is a proper road, this is a gully, we can say that. Okay, so fair enough, but in the case of graphs we have some terminologies or some words that needs to be respected. Now you can say that why those definitions or terminologies are required. This is because some graph specific problem, okay, because graph specific problem do require the use of terminology. Okay, like they would be just telling you that vertices, path, okay, nodes and all. So we can say that this is node or vertices. This is referred to as node or vertices. This is referred to as path or edge. Okay, please remember this by heart. So we can safely say that धनबाद और तमिलनाडु के बीच एक edge है, okay, और path है. और हम लोग ये भी बोल सकते हैं कि धनबाद यूपी तमिलनाडु कानपुर ये एक city नहीं बल्कि एक nodes और vertices है. Nodes और vertices, both of them is very important. Okay, Diwali special class, I think we need to term it as post Diwali special class. Okay, fair enough. So, am I clear till this point or not? Okay, so there are some few terminologies that needs to be well understood. So, as you know, suppose from my house, okay, this is my house, said, and adjacent to me is someone, okay, adjacent to me is Nekach, okay, Nekach's house, okay. So suppose I can say that this is a one-way road. Okay. So I can say that from my house I can go to Nakaj house, but there is no road to come back. Like there is a one-way road. Now we say that like this is a one-way road. So this one-way road and all are referred to as directional graph. Okay, directional road. Okay, okay, directed graph, or you can say it as directed graph. What is this? This is simply one way road. Okay, just write it somewhere so that you remember it. Okay. Now, suppose this is a proper road where I can go to Nakad's house and Nakad can visit me, and we both can do the same. Like we can visit each other's house and then we can come back. If this is the scenario, then we can safely say that this is an undirected graph. Okay. मतलब अगर आना जाना कर सकते हैं तो अनडायरेक्टेड ग्राफ, सिर्फ जाना या सिर्फ आना कर सकते हैं तो वो वन वे ग्राफ. Okay, this is either way. Okay, am I clear with the terminologies or not? There are many other terminologies, but for this class we just need the terminologies of this. Okay, am I clear with these all or not? Just quickly tell me. Okay, so till then I would be showing you, so many a times the graph, you need to visualize the graph. Okay, because in programming we don't really draw the graph, so many a times we see na, ki if we draw the graph it would be more easy to, it would be more easy to say that. Okay, so many a times what we do is we need to visualize the graph. Visualize मतलब हम लोग समझ सकते हैं कि बहुत बार हमें वो चीज सोचना पड़ता है. So that sochna thing is very much crucial, very much difficult if the number of vertices are many more. Suppose you need to draw the network of roads of your house. So if your house, मतलब आपके घर की नक्शा में बनाने थी तो आप दिमाग में बना सकते हो. If I give you to draw the map of your house, you would be able to draw it in your brain. But if I give you to draw the map of the whole city, then it won't be feasible to you. So many a times you need a proper way to visualize the graph in a correct form. Okay, so I use this. Okay, many people has their own preference, but for me I use this one. Okay, so this is a very good website that you can refer to, and I have been using for the last 3 years now. So this is not a promotion, nothing else. Okay, so I use this like 1 0. Okay, like there is a graph, and then we have 2 3. Okay, like we just write it 1 2 2 3 4 5, and it would be there like 3 and 5. We can just add an edge like this, and we can make it like this also. See, okay, like we can make an edge from 3 to 0 also. Okay, 3 to 0 also we can quickly make it, and then 1 to 3. If I want to make 1 to 3, simply if I want to make it this is an undirected graph because we don't have any edge. If we want to make it directed, then we can simply click it like this. Say this is now directed graph. So this is very easy to handle, and I think that this will be quite helpful. So you can take help of that. So this is the website I'm talking about. This is not a promotion, nothing else. This is my personal profiles that I have been using for the last 3 years. Okay, fair enough. Let's move forward. Am I clear with the terminologies or not? Can I move forward? Just give me a quick one in the chat. Can I move forward or not? Okay, seems like I need to cut my beard. It's looking very odd. Actually, I was growing my beard so that I do look good in traditional. But I think I need to get back to formals now. So quickly reply me with the one. कभी सिंह बनना है तुमको सर? I don't think so. Okay. Because I'm not at all impressed by his personality. For me, he is toxic. He was toxic. That character was toxic. Okay. Fair enough. So let us move forward. So we saw that we can have graphs. Now the very first thing is we know that this is graph. But if I say you that I want to have this graph, okay, like suppose I want to have this kind of graph. 1 says 0, 0 said 2, 2 said 3. If I want to have this kind of graph, okay. So if I want to have this kind of graph, then you can observe that I can't really draw. Okay, like this is not a MS Paint or something where I can really draw a graph and I can do things. So if I'm needed with the thing known as graph, I need to store the graph. So storing is a big option here. So we represent the graph in two forms. The very first form is that we represent the graph in matrix. Okay, we represent the graph in matrix representation. Then we use the adjacency list representation. Adjacency list representation. Okay, fair enough. Now, suppose I would just draw a very small graph where we have 1 to 2, 2 to 3, and this one 2 to 4. Okay, and this is like this. So if we are given like this, then I can say that to store the information of 4 nodes, I need a matrix of 4 multiplied by 4. Okay, and then I would be stuck, and then I need to draw this. 1 2 3 4 1 2 3 4 chalo बढ़िया है. And then we can say that this is, so see, this is 1 2 3 4, this is 1 2 3 4. So do we have a path from 1 to 1? Yes, we can reach 1 to 1, so that would be 1. Can we reach 1 to 2? Yes, we can reach 1 to 2. मतलब जो डायरेक्ट पाथ है ना, हम लोग ऐसे बोलते हैं कि हम लोग धनबाद से कहाँ कहाँ जा सकते हैं बिना वाया थिंक किए. तो धनबाद के एडजेसेंट में बिहार है, बराकर है, आसनसोल है. Okay, like suppose adjacent to Dhanbad, we can directly go to Barakar, we can directly go to Asansol, we can directly go to Bihar, Patna now. So in the same way, from 1, I can directly visit 2 and 4, but not 3. Why? Because there is not a direct edge to 3. Okay, please understand this difference. Okay, whenever I see that this can be reached with this just means that there is no via edge kind of thing. Okay, so from 4 I can reach 2, I can reach 1, but I can't reach really 3 because there is not a direct edge. Yes, there is a path that is there, but there is no direct edge. Please remember this. Okay, path है, रास्ता है, मगर direct road नहीं है. Please remember this. Okay, so 1 to 2 we have that. Okay, 1 to 2 we really do have that. Then 1 to 3, no, we don't have that, that would be 0. 1 to 4 we do have that. And then from 2 to 1 we have that. Then 2 to 2 we have that, because suppose I want to visit myself only, so I am sitting here only. 2 to 3 we have that. Okay, then 2 to 4 we have that. 2 is connected to everyone, if you observe. 3 is connected to only 2, other than everyone this is false. Okay, 4 is connected to 1 and 2, so that would be 1, everything else would be 0. So this is the way of matrix. Okay, this is the matrix representation. Okay, so next is the adjacency list representation. Adjacency list representation, at the name suggests, it would tell you the adjacent node to everything. Okay, like हम लोग ये बताएंगे कि if we have, हमारे पास अगर 1 2 3 4 है, तो हम बस बोलेंगे हमारे बगल में कौन कौन है. Like we go in a classroom and we say that this girl is sitting behind me, this girl is sitting next to me, this boy is sitting beside me. Okay, like ऐसे बोलते हैं ना, we do say so. In the same way, I can say that the adjacent node to 1 is 2 and 4. So I would just say 2 and 4. The adjacent node to 2 is 3, 4 and 1. 3, 4 and 1. The adjacent node to 3 is 2. The adjacent node to 4 is 1 and 2. Okay, that is why this is known as adjacency list representation. So 4 to 4 should be 1. Okay, sorry, 4 to 4 should be 1. So absolutely sorry. Okay, so 2 to 2, so 3 to 3 should also be 1. Sorry, I missed this. Okay, I think this is fine. Okay, so this is the adjacency list representation. So am I clear? Am I clear with the problem statement? So am I just clear? Hi Ujjwal, how are you? So problem link is mentioned in the previous chat, and I would be telling you as we move forward. Okay. So quickly give me a one. I would be waiting for the next 1 minute, and then I would be moving forward. Quickly give me a one. Okay, Abhinav is also there. So Abhinav is the one who takes the stream every day. So you can take me as substitute mentor. Okay, we have a lot of one. My day today was a very hectic day. I was not. I don't feel like working. Everyone was just cracking crackers and all. Okay, but still I had to work. Work is work, man. What about you? Fair enough. So we are done with this one. So हमने ग्राफ बनाया. Okay. हमने ग्राफ को स्टोर भी कर लिया. We made a graph and then we were able to store the graph or represent the graph in terms of program. So we are done. Okay, like एक घर था. पहले हमने like suppose there is a house. We saw, suppose we took, let's take the example same one. Okay, so we had a network of roads. First we understood that this is the network of roads. Then we had the network of roads in terms of programming. So what is the next step that we should do? So after we have laid out the roads or laid out the network of roads, the very next thing that we should think about is we should think about traversing or traveling in that road. So now the very next thing is that I need to travel the road. Okay, so traveling is the next agenda of this. So to travel the road, we basically have two ways. The very first way is depth first search. Okay, that is known as DFS, depth first search. And the very next one is BFS, breadth first search. Okay, these are the two ways we can think of to traverse the graph. Okay, data structure to store the graph. This is a simple n into n matrix, and this is nothing but if you are working with C++, this is vector of arrays and array list also. Fair enough. So these are the ways of traversing in the graph. So the very first is that we would be starting off with a very simple algorithm, that is depth first search. Okay, so let me just copy it down. Shall we are done. So this is depth first search. Now depth first search can be implemented recursively as well as iteratively. Okay, but iterative is your homework for today, and recursive, which is the more easier, which is just of two lines, would be the one we would be doing it. Okay, so to traverse the graph, let us first have a graph. Okay, so let us have a graph quickly. One, two, 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 three, and then three, four, three, two, four, three, two, four. Okay, we have made like this. Then let's have a simple like this is the graph. And now let's first have the adjacency list representation of graph. Okay, so we have the adjacency list representation of 1, 2, 3, 4. So what are the neighbors of 1? The neighbors of 1 are 2 and 3. The neighbors of 2 are 1 and 3. The neighbors of 3 are 1, 2, and 4. 1, 2, and 4. The neighbors of 4 is nothing but simply a value 3. Am I clear with these all or not? Like this is the graph, this is the adjacency list. I won't be waiting. Simply give me a quick one in the chat. And everyone, please like the video. The number of likes is absolutely very less. Okay. Okay. So quickly give me a one. This is clear. So now let me just introduce you to the code of DFS. So basically DFS is nothing but a depth first search where we get a node, we visit all its neighbor. We get a node, visit all its neighbors. Simply, this is just it. Okay. So what we have is, so traveling. Traveling means we just need to travel. Okay. So I would just make the return type of this as void. So let me just code it also. Okay. Then I would explain you the code part. So the very first thing is I would have a void DFS, I would have a source. I would explain that. As of now, just let me write and then I would explain. Just give me 1 second. Visited of source is equal to 3. Then for auto E of G of S. Okay. If visited of S is equals to false, then rec of, okay, visited of E is equal to false, then rec of E is to be 10. And this is done. So let me just take the screenshot of this. Because when I was in my initial days, understanding the code of DFS was absolutely very difficult. Okay. So let me first tell you. This is the graph G. This is the graph G. Okay. And then we have a visited array. Okay. 1 is initialized with 0, 2 is initialized with 0, 3 is initialized with 0, 4 is initialized with 0. So everyone in the starting phase is a 0, that it is not visited. Okay. Hope I am clear till this point. Give me a quick one, give me a 0 if this is not clear. So bro, in Java, I think this code requires auto E. This is just traversing the parts. Okay, I will just explain you the code, don't worry. Okay, what is the difference between this and DFS is an array tree? There is a very big difference. When you would be doing tree, you would understand. This is recursive. Yes, the recursive code is to be done today, and the iterative, which is not that greatly used apart from understanding it. So you can just use it. You can just treat it as a homework. Okay. So please repeat from the start if possible. So start is 30 minutes back. So 30 minutes, I need to repeat again, that would be 1 hour. I don't think that is feasible. Repeating is not feasible. I can briefly explain you. But repeating from the very start won't do a justice to everyone. Okay, so let's say, okay, this problem only. So this problem is nothing, but we are trying to do a depth first search. What is depth first search? Depth first search is nothing but a way to traverse the graph. Okay, so first we made a graph like this. We made the adjacency list representation of this. We wrote the code of DFS, which I have not told you. And this is the visited array initially that is taken before doing a DFS. Okay, एक बार हिंदी में जल्दी से समझ लेते हैं, ठीक है. सो सबसे पहले ग्राफ बनाया तो अब ये भी समझ रहे हैं ना प्रोग्रामिंग में कैसा है. प्रोग्रामिंग में भैया आपका ऐसा है, ठीक है. उसके बाद आपके मैंने कोड लिख दिया, जो मैंने कोड अभी तक समझाया नहीं है. वो कोड आपको तभी समझ में आएगा जब इसका मैं ड्राई रन करूंगा. अब इस पे एक कॉन्सेप्ट यूज होता है ग्राफ पे, जो है विजिटेड एरे. विजिटेड एरे कुछ नहीं है, बस एक एरे है सिंपल सा, जो ये बताता है कि वो एलिमेंट अभी तक विजिट हुआ है या नहीं. सिंपल सा, मतलब मेरे एक दोस्त खड़ा है जो मुझे बताते जाएगा कि भैया आपका ये चीज हुआ है कि नहीं हुआ. दिस इज जस्ट लाइक कीपिंग अ ट्रैक इन अ कंपनी. Now am I clear? Nikshat and everyone else. Okay, let's move forward. So the very first thing is, let's say we pass the source as 1. So source is equal to 1. So first visited of source is equals to 1. So we would mark the visited of source as 1. Okay. I have explained you in either of the languages. First I've explained you in English, then I've translated the same in Hindi so that people would have a better understanding. Okay. Graph may duplicate Soto. As of now, we won't be going into that. So most of the time there won't be any duplicates. Like you won't see like this. One is connected to one. That is why I told you that visualize it in terms of network of roads. Like Kanpur, there is no road from Kanpur to Kanpur. Okay. So there won't be anything like that. Don't worry. Okay. Fair enough. Thanks से नहीं चलेगा. So thanks won't work, Vikshar. I think I need a chocolate from you. For disconnected graph, this can break. Yes, I will tell you. Okay, don't worry. We would be learning about disconnected graph, connected components in the last question. Okay. So in the second question, to be honest. Okay, so we went to visited of S is equals to true. Then we are visiting the neighbors of S. G of S is 1. Okay, G of 1. G of 1. Now we would be visiting the neighbors जो visit नहीं हुआ. So I would be just summing up the small code of this. Okay, this is just like this. That suppose, so this can be visualized like this. Okay, like suppose there is a Casanova kind of person. Okay, like a person who has a lot of friends. Okay, like he's a very cool dude kind of thing. Okay, let's take an example of this. Okay, suppose there is a very cool dude kind of person. Okay, let's draw the person. Okay, so I can say that he is a very cool dude kind of person. So what he does is he meets with a new people. Okay, who is not his friend. Okay, meets with a new person who is not his friend. Now, what he would do is first he would make friendship with this person. Now, this person is a friend of this cool dude. Now, the people, okay, the folks who are the friend of these all person, like let us take an example. Like suppose this is Kunal, okay, and this cool dude is, let us see, let us say ask some cool dude. Let's take the same. Let's see a different person. Okay, Sachin. Okay, I think Sachin. Okay, suppose this cool dude person is Sachin, then it would be more clear. Suppose Sachin is a very cool dude kind of person. He makes friendship with Kunal, and Kunal friends are Siddharth, that is me. Okay, and then there is Victor, and then there is Nakaj. Okay, now let's see the scenario. So Sachin is a very cool dude kind of person. He makes friendship with Kunal, and then all the friends who are friends of Kunal but not the friends of Sachin, he would make friendship with these all people also. Okay, like cool dudes are very contagious. वो जहाँ जाते दोस्ती बना लेते हैं. They're very friendly. Wherever they go, they make friends. We have seen this scenario. Are you understanding this scenario? Give me a quick one. And this is basically a DF system. Okay, like there is a person who makes friendship with that person, and the person of that person who is not friendship with this person, we make friendship with them. Am I clear? Nico Janal, quickly. I would tell you why it is called depth first search. I would tell you. Okay, why का मतलब क्यों कहते हैं वो बात में समझ लेते हैं. First, see, whenever you see a girl, okay, suppose the name of the girl is, suppose Shreya. Shreya is the name of my sister. Don't get it wrong. Shreya Hazra is the name of my sister. Suppose I saw my sister. Okay, so first I would ask the meaning of my sister's name, or first I would ask how is she, how can I treat her. This would be the thing. Na? So first I would understand what is DFS, how does it work, how to code it. Then we would ask why is the name like that. So okay, we would answer that thing at the end. Okay, so fair enough. So now this thing is very contagious. So we visit this one. Then all the neighbors of one which is not visited, we would visit them. Okay. So first one is now visited. One is now visited. Then we go to three, which is not visited. And then we would visit it. Okay. Then we would visit it. We would just pass it to rec. Rec of visited of one. Okay, just see it. First we are doing DFS of one. The neighbors of one which is not visited, which is DFS of three. Okay. Now, neighbors of 3 which are not visited. Okay, then we would visit 3. Neighbors of 3 which is not visited, what is this? There are 2 and 4. So now first we would go to 2. We would go to 2. So neighbors of 2. So first we would visit 2. So neighbors of 2 which is not visited. Any of the neighbors? No, 3 is also visited, 1 is also visited. So this is done. Then other neighbor of 3 which is not visited is 4. So now DFS of 4, we would first visit it, and then after that point of time, every neighbor of 4 is visited. So this is done. Every neighbor of 2 is visited. This is done. Every neighbor of 3 is visited. This is done. Every neighbor of 1 is visited. So if you see that after visiting all the neighbors of the current node, the work is done. Okay, so basically, if you observe that, why is this called depth first search? Because this is 1, it is going to 3, then it is going to 2. Okay, then it is from 2. If there was some other node, wo pehle wahan jayega. Then it is coming back. So it is going in depth kind of thing. Okay, it is just going in depth kind of thing. That is why this is known as depth first search. First, it would complete the depth, and then it would go to that node. If you observe that first it completed, okay, first it does complete the 2, then it comes back to the other neighbor, that is the next node, that is 4. Now am I clear? Adarsh, am I clear now? First deep, then wide. Yeah, absolutely. So we are going from top to bottom in depth. No one should be left if connected with the node. Yes, absolutely. As of now, think that there won't be any disconnected thing. Disconnected cheese abhi picture mein hai hi nahi. We didn't have any knowledge about disconnected graph. Have I explained you what is disconnected? No, no. That is why. Can we say it as a backtracking approach? Yes, we can say. Like what we can say is like what is the main example? Okay, like what is this example I'm telling you? The example can be that suppose I sat to study. Okay, I need to do suppose, let us take a very simple example. Okay, like suppose I need to do searching. Okay, I need to study today searching, and I need to study today sorting. Okay, please see this with absolute care. Like I sat down today to study. Okay, let's take the scenario. Like suppose I'm a very noob kind of person, and I have a girl to impress of my class, and I want to complete the topics, and then I want to explain to her so that she would be impressed. Okay, so to do that I need to complete searching and sorting. Okay, I go to searching part, and then I saw that on the searching thing I need to complete binary search, and I also need to complete linear search. Okay, so मैं क्या करूँगा? What would we do? We would first complete binary search, linear search, and then we would come back to searching, and then we would move to sorting. Same thing we are doing in this DFS also. Like we are from 1, we are going to 3, then from 3 we are going to 4, and then we are coming back to the next thing that is left, that is 2. So first we are going in depth. If you observe that this is also depth first search kind of approach. First searching, then binary search, linear search. Do we leave it midway and then we come back to sorting? No, we don't do it. This is a proper real life scenario of depth first search. Now, am I clear what is depth first search? Why is the name depth first search? What is the idea of depth first search? Are you able to relate it with a real life example that is given? This would be 1 2 4 2 1 2 3 4. Okay, yeah, the way can be anything. The way can be anything. Okay, we don't really care about the way. The only thing we are concerned about is we want to just visit all there. Suppose I went to visit the world tour, and I don't have any constraint on the budget. Okay, like मुझे बाहर घूमना 6 cities घूमना, मुझे मुझे दिन की constraint नहीं, मुझे time की constraint नहीं है, मुझे पैसे की constraint नहीं है. अगर ये दोनों constraint ना हो, so I can visit the cities in either of the ways. If we are not concerned about the timings, if we are not concerned about the time frame, if we are not concerned about the budget, then we can visit it according to our wish. Same happens with DFS also. Like either of the way is fine. Like 1 3 4 2 is also fine, 1 2 3 4 is also fine. Okay, fair enough. So I should be clear. So the thing is, so what I want you to do is, I will just give you 1 minute of time. Okay, 1 minute of time. So what I want you to do is, just after the DFS, just write the example. Okay, and below the code, just write the example also. Like whatever example I have attached with it, please write the example, like the school tour example kind of thing, and this example kind of thing. Please write it quickly. Okay, theory आपको कहीं और मिल जाएगा, but if you are able to relate it with a funny example, then you would be able to retain it for a longer period of time. Like suppose after a month also, if you go and see the notes and you remember this funny example, then trust me, you would be able to recall everything. So quickly write it and then give me a quick one. I would be waiting for the next 1 minute. Can you explain the code again, sir? No worries, I would be writing the code again. Okay, I would be writing the code again. And sir na bulao bhai mera, Siddharth bulao, Sid bulao, bhai bulao. Okay, Siddhu bulao. Sir mat bulao. Sir seems a very formal kind of thing. Do I keep it formal? I want to keep this informal but yet informative. So don't call me sir, brother. I don't think I'm that great old or some senior kind of person. Okay, most of you would be of my age or either senior than me or a little bit junior than me. बीएफएस का कोड ऑल्सो भैया, अरे सब एक्सप्लेन करेंगे, सब एक्सप्लेन करेंगे, हम है ना भैया, टेंशन नहीं. ओके, thanks. You would definitely impressed. Well, okay, fair enough. Thanks a lot. I think this is a cultivist kind of person. Yeah, this video would be present on Geeks for Geeks channel. Okay, every live stream would be present as past stream. Chalo, quickly give me a one after you have wrote the example that I have just told you. Quickly write the example, and then I would move forward. Quickly write the example. देखो भैया कितना सुनने में अच्छा लगता है. N factorial using recursion. This is not a class of recursion. This is a class of depth. This is a class of graphs. When you started upcoming week for week course, Geeks for week, when you started upcoming, there is a course that is going on. CP14, Competitive Programming 40, is going on with me being the sole mentor. Okay. Just quickly give me a one after you have done writing it in a pen and paper. Quickly give me a one. Quickly. I don't want to waste more. Quickly give me a one after you are done. Pramod and all, quickly. Prathviv, Kunal, Komal, Adarsh, Shubham, SK Chand, Okay, fair enough. So, are you able to see me? Just give me a quick one in the chat. Quickly give me a one in the chat if you are able to see me. पता नहीं था ये भी बोलना पड़ेगा. I wanted to maybe the workout example like higher level. अरे 0 मिनट पे आ गया. चलो बढ़िया बढ़िया बढ़िया. Am I buffering a bit? Might think that I might buffer a bit. दिवाली की मिठाई खिलाओ सिट ब्रो. अरे आपको पढ़ा रहा हूँ, आपको खिलाना चाहिए. I think yes. Now it would be fine. Actually, what happened was my battery went down. Okay. जॉब लगना तो फिर खिलाएंगे. अरे सही है सही है एकदम सही है. जॉब मिलेगा तो पार्टी चलेगा, मिठाई से नहीं चलेगा. Okay, fair enough. Let's go back to the thing which we were doing. Sure, fair enough. So the next was searching and the sorting thing. Okay, so let me just turn on my previous screen. Okay, just let me turn on. Thanks a lot. Okay, okay, fair enough. This is done. So now the code of DFS, I would explain you again. So the code of DFS is very easy. First, we would maintain a visited array like this. Then we would be visiting each node of that particular array. Like this one has all the things that is there, and then we would visit it. And then if it is not visited, if the mark attached one is not visited, we would just pass it to the function. Okay. I think that this is done. The only mistake that is there is I have named this as rect. This would be D. Now am I clear with the code? Quickly give me a one. Then we would Then we would be discussing about the connected and disconnected graph, connected components and all. Quickly give me a one in the chat. Okay. Quickly give me a one. फिर we would start the next thing. जॉब लगने दो फिर खिलाएंगे. ओके. आदर्श ब्रो सेंड मी द एड्रेस. अभी चॉकलेट भेजता हूँ. आप अभी के लिए रहने देते हैं. When you would get a job because of me, then I would receive a chocolate with with great hands. Okay. As of now, chocolate is not required. When I would be the reason of you for getting a job, I would be more than happy to receive a chocolate. What is G of S? G of S is nothing but this graph only. See, this is written. The graph only. G. This one is the G thing. Okay. Like G of 1 dot pushback. Okay. Fair enough. Time complexity would be big O of n. Why time complexity big O of n? Because if you observe that we are visiting each of the node exactly once, that is why the time complexity to this is big O of n. Okay. Chal, we are done with this. Anyone who has not understood this? No, there is no one. Okay. Chalo, let's move forward to the next one. So now we say that we have a graph like this. Okay, let's make the graph like this. We have a graph like this. Then we have 1, 2, 3, 4. Then we have 5, 5 to 6, 6 to 8. Okay. Then 8 to 7. Okay. Then 7 to 6. 9746. Okay, like this kind of graph. Okay, then here we have minus 2. Okay, fair enough. So this is known as a disconnected graph. Why it is disconnected graph? So what is connected graph? What is disconnected graph? Let us first understand that. Okay. So what do we say in layman's language? Okay. We do say that this we do say that these are all connected. We can visit each of the which we can visit each of the cities in either of the ways. Suppose we saw this now, like Dhanbad, Kanpur, Tamil Nadu, and UP. So we can say that these are connected. Why? Because from Kanpur I can visit all the other states. From Tamil Nadu I can visit all the other states. Okay. From the UP I can visit all the other states. Okay. Okay, fair enough. This is what we can say. But suppose there is one more state. Okay, suppose let's say take the example of London, which was provided. Okay, so let's take the example of this. Okay, and this one as France. Okay, so now I can say that this is not connected. Okay, this is not connected. So as of now, the question is what is connected graph, what is disconnected graph. Okay, so I can say that London and France are not connected, and this is. So in the same way, can you tell me that this is an example of connected graph? So this is a connect. Which one is a connected graph? Okay, like I will just quickly. So can you tell me which is a disconnected graph, A or B? One is disconnected, one is connected. So now tell me which graph is disconnected. So this would be quite easy. Okay, so A and B. So tell me which is the disconnected graph. A is a disconnected graph or B is a disconnected graph. So now everyone is clear with A and B. Okay, visualize in terms of the network of things as said. Fair enough. Now let us move forward to the very next thing that is there. So now suppose we are given a graph like this. We are given a graph like this. Okay. Now the question is count the number of components. Quickly tell me the count the number of components. How can we do it? Tell me. So if you are given a graph like this and we are told to count the number of connected components. Tell me how can we count the number? No, the question is not the number of connected components. The question is that how can we do it? The question is how. Number of connected components is 3. Connected components is 3. Now tell me how we can have it. Tell me that. How we can have how we can count the number of connected components. Tell me. How much time we have to do DFS from visiting all the liquid groups. Okay, absolutely. Lucifer. This is the way. So what I can do is I would just tell you how to do that. Okay. So first I would make an array. Two, 3, 4, 5, 6, 7, 8, Initially, everyone is disconnected. Okay, everyone is not visited. So first we would start at DFS. Okay, from 1. 1 is visited, no, 1 is not visited. So if we start a DFS from 1, then 1 would be visited, 2 would be visited, 3 would be visited, 4 would be visited. So 1, 1, 1, 1. After that we would come to 2. 2 is now visited, 3 is also visited, 4 is also visited. So how many DFS is done? As of now the DFS done is 1. Okay. Then we would come to 5. 5 is not visited. So we would come to 5 and we would start a DFS. 5 visit, 6 visit, 8 visit, 7 visit. Okay. 5, 6, 7, 8. Then we would check for 5. 5 is visited now, 6 is visited now, 7 is visited now, 8 is visited now. Then the unvisited is 9. So now we would visit the ninth one. So now we would visit this, now we would visit this. So both would be 1 and 1. So how many times did we do a DFS? We did 3 times the DFS. So we can say that the total number of DFS required to visit all the nodes is the number of connected components. Okay, मतलब पहले 1 पे जा रहे हैं, 1 विजिटेड नहीं है, सबको 1 के अगल बगल जितना है जो डीएफएस से पहुंच सकते हैं सबको विजिट कर लिए. फिर हम लोग 5 पे जा रहे हैं. ओके, फिर हम लोग 4 पे जा रहे हैं. 4 में और अगल बगल कुछ विजिटेड नहीं है. 5 पे गए, अगल बगल विजिटेड नहीं है. वी विजिट एवरीथिंग दैट इज ऑन 5. Okay, 9, 10, that is also done. So now quickly give me a 1 if this question is understood. Quickly give me a 1. I was thinking to use set. No, I don't think set is required. Okay, because see, every time the nodes would be in a concise manner. So now the next thing what I want is I want you to see this question. Number of yes, I want you to see this question. Just let me see. Please see this question. And this is the link of the question. Now give me a 1. Okay, give me a 1 if you can solve this question. Give me a 1. अगर ये क्वेश्चन देख के आइडिया हो रहा है ना कि हाँ इसको मैं सॉल्व कर लूंगा तो गिव मी अ 1. If you are getting an idea to solve the question, quickly give me a 1 in the chat. After you are seeing this question, if you are able to tell that yes ये solve हो जाएगा, so just give me a 1. Asking number. Mohit, what problem do we have? Can you quickly tell me? This is an undirected graph. Undirected. It is told that this is given an undirected graph. It is told in this question. Given an undirected graph. Chalo, everyone is able to understand. Anyone who is not able to understand? What is undirected graph is? Undirected graph is completed with the use of undirected explanation of undirected graph is done by this example also. I think I have explained you. Chalo, now the next thing we will be doing is we will be doing breadth first search. But before that, let us take an example. Let us take some 1 minute rest. Problem link, sir. Problem link is already mentioned. Still, I will just again paste it. Okay. Q&A for next 1 minute. Hmm. Let's take rest for 1 minute and then we will start with BFS. N nodes of the graph should have n multiplied by n plus integer. Sir, can you discuss some hard level question? This is a medium level question. So I have introduced you with the topic of graph. So people, I'm introducing you to the topic of graph. Then within a span of 1.5 hours or 1 hour, it is not really feasible to explain you the hard problems too. Is Love Babbar and Nishant from your college? No, absolutely not. I am from Netaji Subhash Engineering College. That is a very small tier 3 private college in Kolkata. Don't confuse it with Netaji Subhash Institute of Technology. NSIT is different. NSEC, that is Netaji Subhash Engineering College, is different. Okay. भैया प्लेटफॉर्म एल्गोरिथम में डीएफएस बेटर रहता है या बीएफएस? डीएफएस इज बेटर. हाय गायत्री तिवारी. What is the time complexity of algorithm in this question? So basically we are visiting each of the node exactly once. So I can say that the time complexity of this algorithm is big O of m because we are visiting each node exactly once. Sir, will we be studying graphs in the upcoming classes? I think graph would take 1 or 2 more days time and then we will be moving forward. Is connected to another in that component. Let me see this question. No, it is not mandatory that the number of edges would be this. Number of nodes would be n only. Number of nodes would be n only, not more nor less. Okay. Chalo, let's move to the next problem. So much here. Okay. NSIT is best. Yes, NSIT is best. But my college is NSEC. That is Netaji Subhash Engineering College, not NSIT. Please remember this. Okay. So this is done. DFS is done. Now the very next thing is breadth first search. Okay. So we saw. Okay. So we saw that we were learning. So where is this example? Yes. We saw that we were learning like this. Okay. So let me just take. So suppose this is me. Okay. This is searching. Same example. Suppose I'm trying to learn searching and I'm trying to learn sorting. Okay. Searching. For searching, the very first topic is binary search. Okay. So this is now the very first topic. Like, let's make it very realistic. The very first topic is linear search and then is binary search. Okay. And for sorting, I can say that first is bubble sort and then is selection sort. Okay. So if okay, number of provinces problem. Okay. So fair enough. So see, the number of provinces. Okay. So see, We are moving forward with the searching, and we saw that if we kind of want to have this first searching, then linear, then binary, and then we come back again, then we move to sorting, bubble sort, and selection sort. If this was to be done, if this was to be done, then I can simply say that we can use DFS. But suppose I want to have this, that first I would complete searching, sorting, definition, then I would complete linear search and bubble search. Okay, linear searching and bubble sorting, then binary search and selection sort. If I want to have this kind of thing, like what I want to convey is, first I would complete all this, then I would complete all this, then I would complete all this. If I want to have this kind of thing, then what is the way I can have this? Tell me a way to have this. Suppose I want to visit things in this fashion. Tell me, BFS using Q. How BFS using Q? We would be first understanding it in terms of example of this, and then we would be understanding in terms of the graph. So first let us understand this. So कैसे हम लोग होगा, ठीक है? So first what we would be doing is we would be inserting SID in the queue. Okay, so we would be first taking a queue. Okay, then first I would insert this SID in the queue, the very first source in the queue. Okay, okay. So first we would insert the source, then we would first visit the source. Source is now visited. Okay, this is first visited. This is very first visited. Then the neighbors of SID, that is unvisited. Neighbors are searching and sorting. So I would remove this SID and I would insert searching. First I would insert everything. Okay, first I would insert searching. Searching, and then I would insert sorting. Okay, fair enough. Then I would take out this searching. I would take out this searching. First I would visit it. Okay, mark it visited. Then I would say that the neighbors of searching, which is unvisited, I need to insert them at the back of the queue. So it is linear. Okay, and it is done. Okay, we visited the searching thing next time. Okay, then the next is sorting. So first we would take out this sorting, then we would visit it, we would mark it visited, then the neighbors. So first we would make this go to the front, then the neighbors of sorting, which is unvisited, we would insert it to the queue. Okay, we have inserted it to the queue. Now we would remove the sorting thing. Now comes the linear part. So we would first visit the linear. So 3, this is the fourth visit. And then we would insert the neighbors of linear into the queue. That is binary. And then we would remove this. Okay. Then we would take out the very first node of, then we would mark it as 5. Then we would remove it. Okay, and then the neighbors of 5, that is selection, we would insert it. Okay, now the binary thing is that it is the 6th visited. So the neighbors of binary are nothing which is unvisited. So remove it and we would mark it as visited. Then comes the selection. So first we would visit it, the 7th number, and then the neighbors of selection, which is unvisited. Everyone is visited. So now if you observe, that we first visited this, then we visited these two, then we visited these two, then we visited these two. So now am I clear how we are visiting? So the whole part is that the whole theory is we would take a queue, then we would insert the source of the queue, insert the source of the queue, then we would insert all neighbors of front of the queue, and then visit the queue, visit the front, and this is DFS. Now, am I clear with a real life example? So, those who have learned DFS before only, okay, they can judge by my explanation that this is good enough for beginners or not. So, just quickly judge my explanation if you are already familiar with this thing. Yes, the famous Dijkstra algorithm is based on this BFS. So if you already knew BFS, okay, feel free to just tell that this was a good explanation or not, so that people who are not aware, or people who are not paying attention, okay, so they can just tell that people, if someone is telling good about that, we just look at if it is good or not. Okay, fair enough. So now let us see this in terms of the graph. Thanks a lot, Adarsh. Thanks a lot, Prithviv. Thanks a lot, Nakaj. So now let us see this in terms of the graph that is given. Okay. Suppose we have 1, we have 2, and we have 3. Simple. Okay. So basically we are given with a source. Okay. So we would insert this in a queue. Okay. Because see, this visualization which I'm doing now is available readily on the internet, but never really found this kind of explanation. So I thought this kind of explanation should be done. Okay, so now a queue should be there. We are given with a source, so first we insert the source and visit it. So this is what is given: insert the source and we visit it. So we insert the source and then we mark it as visited. Okay, then we take out the source and we insert the neighbors of the source, that is 2 and 3. Then we remove the source, then we see the 2, first we visit it, then the neighbors of 2 which is unvisited. Neighbors of 2 is just 1 which is already visited, so we won't do anything, we will just take it out. The neighbors of 3 which is unvisited, there is no one, so we would simply visit it. So now you can see that we were able to visit like this, then visit like this. Seems like level order traversal. Yes, absolutely. Seems like this is a kind of level order traversal. Okay. So now am I clear? Am I clear with this or not? Can I have a quick one in the chat? Then I would start with the code part of this, and then the stream would end after a little bit of chit chat. Quickly give me a one in the chat. Quickly. We need to maintain visited array. Yes, absolutely. We need to maintain a visited array. But visited array maintenance is already shown 2 times in DFS. So I don't think you would have a problem. Okay, quickly give me a one. Nakshat, you are understanding now, na? Chalo, Nakshat is also understanding. He was the one who attended late. Okay, chalo. Let's code it then. So we are given an adjacency graph. So let's code it in this fashion only. Simple. And suppose we are given an adjacency graph like this. Adjacency graph is already there. Okay. This is the graph. And the number of nodes are n. Okay. So n is the number of nodes and s is the source. Okay. So first I would make a visited array. So int visited of size n. Then I would mark everything as not visited. For int I is equals to less than n and I is plus plus. And first I would make everything as not visited. Visited of I is equals to 0. Okay, everything is not visited initially. Then what we would do is we would insert the source in the queue. So we would first make a queue and queue, and then we would push the source in the queue. And then we would make visited of source is equal to true. Okay, this is done. Then we would say while the queue is not empty, we kept doing it. So while queue dot empty, while the queue is not empty, first we would take out the front of the queue. Okay, we would take out the front of the queue. So int front f is equals to queue dot front. Then we would remove it from the queue because we have taken it and then we have saved it. Okay, so queue dot pop. Okay, this is done. So we have taken it and then we have saved it. Now we are removing it from the queue. Then we need to visit the neighbors of the front element which are unvisited. So for auto e of g of f, and if this is visited of e is equals to false, then q dot push this element. Okay, that is e, and we would make visited of e is equal to true. And after this, the BFS would be done. Okay, or else you can just do like this. After taking out from the front element, visited of f is equal to true, so that you don't need to do this. Now the BFS is done. Okay, sorry. No, NQ is not in used. Q dot push is so Q. Just let me see. NQ is not used in C++. I don't think, but still, let me just check it. Only push would solve the purpose. Let me just see. बहुत दुनिया में दुख है. Q dot push. Q dot push. Q dot push. I am right. NQ you used in I think Java. Okay. So now am I clear with the code or not? Am I clear with the code? Send me a quick one so that I can take a leave. I can take a leave after 5 minutes of chit chatting. So quickly give me a one if this code is clear. And you can just use this code and copy paste it in here. My main focus is not the coding part. The main focus of mine is just the explanation part and the simple implementation of it. Implementation is just 10% of it. Main is the explanation. Like if you are able to explain and if you have good implementation skill, you don't need to remember the implementation. Okay, quickly give me a one. Yes, I am using this. Thanks a lot, Kunal. Okay, fair enough. So explanation time. Okay, fair enough. So I think this is now done. So Q&A for the next 1 minute. Q&A. Tell. So now Q&A. And then after a little bit of chit chat of 2 minutes, I would just end the session. Okay. Or let us name it Ask Me Anything. Okay, fair enough. Let us see. Yes, I think Java uses this NQ thing. Yeah, when I used to code in Java in my initial days, I used to use this. Next class आप ही लोगे? No, next class, tomorrow's class would be taken by Yash Trivedi. ग्राफ में कॉम्प्लेक्स चेंज क्या है? टू बी ऑनेस्ट ग्राफ में एज सच कॉम्प्लेक्स चीज है नहीं. There is not that much great complex in graph. I think graph is the easiest to solve. Okay, like graph problems are very easy to detect. Okay, but a small thing which you can think of is problematic is, if you're talking about just graph, is the topological sorting. Okay, so Yash Dwivedi, hi Yash. So he would be the one who would be mentoring you tomorrow. I think many people would be knowing him. I think far better than paid course. Okay, thanks a lot. Okay. Sir, topic क्या होता है tomorrow? Yash Dwivedi, can you please reveal the topic of tomorrow? I think he would be better knowing it because he is present in the stream. सर आपका कोडिंग जर्नी कब स्टार्ट हुआ भैया? My coding journey started off from second semester. Mom and dad को मैं thanks a lot. Thanks a lot, Adarsh. Thanks a lot to everyone. Okay, पूरा ग्राफिक कॉम्प्लेक्स है मेरे लिए, बट ग्राफ ग्राफ कॉम्प्लेक्स है. देर इज अ लॉट ऑफ थिंग्स टू कवर इन ग्राफ, but it is feasible. The detection of graph problems is very feasible. Okay, how much time it takes to master DSA? It entirely depends on your level. Okay, like if you have a good catching power, if you are good enough, then you would be some. So everyone has their own timeline. Some take 6 months, some take 6 years, some take 1 year, some takes 2 years. It entirely depends on the time or effort you put in. It entirely depends on your capabilities of your brain. Okay, like we say na, every human has his own clock. Okay, आप कौन सी ईयर भैया? आई एम करेंटली इन माई फोर्थ ईयर. यस. तो ब्रो एड एंड पुल यूज होता है. सर वो कल ही बताएंगे टॉपिक. आप बताओ आप कहाँ जा रहे हैं? आप भी जा रहे हो साथ में? ओके. Okay, fair enough. So that's it for today. So bro, your LinkedIn. Okay, just a second. LinkedIn. This is my LinkedIn ID. ब्रो आज आपने एग्जांपल नहीं दिया जी गर्लफ्रेंड का. आज वैसा कुछ था नहीं. Like see, there are many notes na? So I can't really move forward with example of girlfriend because some might, it's because it is not feasible. Like you won't feel that greatly connected with many girlfriends. Like many girlfriend is not a real life example. So that is why I took many subjects. So in graph, taking the example of girlfriend is not feasible. No, I won't be able to code, but I know the logic behind it, how to overcome this problem. If you are not able to code, that means you have poor implementation skill. If you have poor implementation skill, then I think you should code a lot. Okay. गूगल के लिए ट्राई करे भैया. फाइव स्टार कोडिंग जर्नी इन कोड शेफ. Just keep giving contest, keep up solving, and you would be able to do it. If you're good at coding, that is directly proportional. गूगल के लिए ट्राई करे भैया. As of now, I'm not trying to achieve Google as of now. Okay, you have like this is a very informal type of question. Really said, bro, I like your example and super best. Thanks a lot. You have a GF now. The level of excitement you are showing enough. This is not true. This is not true. Yes, I had one. Okay, but long back. That's a different story altogether. But that is not true. I just take examples of this GFs and all so that people would laugh a little bit, they would feel connected and these all. This doesn't mean that I have a GF girlfriend, that's why I take a lot of examples around her. This is not the correct thing. The correct thing is that I like to make the funny class funny so that you would be able to retain in your brain for a longer period of time. Okay, this is not true. Okay, so that's it for today. I think so. Only 4 seconds are remaining. So mark your attendance in the comment section. Okay, and if you want, you can rate my explanation on a scale of 10. Okay, is the So what is this? Let me just see. Open for opportunity. Oh, links are not in the description in the session. Open for opportunities. No, I'm not open for opportunities. Yes, Duvedi. Yes, Duvedi is open for opportunity. I think so. This is the link for the last problem. ये दुख काहे खत्म नहीं होता सॉरी फॉर आस्किंग इट इट्स एब्सोल्युटली फाइन लाइक आप इनफॉर्मल हो तो मजा ही आता है लाइक वी यू आर इनफॉर्मल विथ मी यू आर टेकिंग इट ऑन अ हेल्दी लेवल इट्स एब्सोल्युटली फाइन ओके ये दुख काहे खत्म नहीं होता अर्लियर इट felt like a duk kind of thing but eventually it started to have like a kind of freedom kind of thing okay it changed to a thing of freedom. Okay. So by the way, still Yash is open for opportunities. You can contact Yash if you think that you have opportunity for him as a boyfriend. Okay. Thanks a lot, everyone. Good night, everyone. Homework question would be provided to you by Abhinav in the Discord, itself. Okay, and the link to the Discord is given in the description. Abhinav would share it. Abhinav, I think Abhinav has already shared it. Just go to that and Abhinav 30 days challenge. I think Abhinav has shared it. Yes, Abhinav has shared it. Okay, fair enough. Tata, bye bye, good night. Thanks a lot, Shubham Kumar. बुढ़ात क्वेश्चन नहीं किया थर्ड सारा क्वेश्चन किया BFS इज डन BFS traversal इज डन जस्ट कॉपी पेस्ट करके इसी ला दो द टाइमिंग इज 10 PM IST हैप्पी दिवाली आदित्य हत्रुक थैंक्स अ लॉट एवरीवन BFS is done. Please keep in mind BFS of a graph is coded and shown in the local network. Please just copy paste it or copy paste from the video by using the extension of Blackbox and you would be able to get an easy. Thank you everyone.